people still play Tetris 99? Wow. No Twitch app, I'm not live. I'm not streaming at all. The hell? The hell? The heck? There we go. I am live. Oh!
So, back in another exciting episode of the C++ Primer series, where we try and learn C++ by going through a book called the C++ Primer. Last session, we tackled the multi-dimensional arrays. We had some cool code, that works, and some cool code that does exactly the same thing in all these circumstances. I am most comfortable with the C style using iterators, but we have direct pointy boy stuff, and we have range iteration techniques from C++ as well. All successful, all work fine. No problems. A little bit of problems. No problems. Multi-dimensional arrays. Boom. Complete. But with the end of multi-dimensional arrays, that was actually the end of the chapter. Will you download? Okay, give me a moment. Acrobat Reader is updating, so I can't actually open the book. You done, son? My screen was dispatched this morning, and I received 4 ancient PS2 games in the mail. Please! It was not done. I opened it and it closed itself. Are you done now? Was closing it signifying that you were ready to open again? I just want to open files. I don't want to sign in. I'm not doing anything. Thank you. Thank you. So, we got to the end of the chapter. We got a little defined term. Defined terms list. Begin and end. Obviously, the terms used to find the begin. It's a member function of string and vector that returns an iterator. The first element, a freestanding library function that takes an array and returns a pointer to the element. Okay. Buffer overflow C-style strings, null terminated character array. String literals are C-style. String literals are C-style strings. C-style strings are inherently error prone. Fuck you. Right, okay. Just because baby boys don't know about memory. Pointer arithmetic has no hyperlink. Arithmetic operations that can be applied to pointers to arrays support the same operations as iterator arithmetic. Yeah, so you got plus plus, you got minus minus for increment and decrement respectively, and you can use subscript. Is it called a subscript? Because it isn't a subscript, it's square brackets, but subscripts to plus plus operator. Oh yeah, okay, there's less than. Oh no, these are output and input operators. Okay, these are. And logical operator or logical operator. Cool. Oh fuck, here it comes. So we're in chapter 4, I guess. Feels like chapter 2 actually, but it's I think the first 2 chapters were just introduction. Chapter 4 is, please, expressions. Whoever formatted this book did not take care to make sure their titles and their stuff were on the right pages. So some part of me thinks that this is maybe not as polished as it could have been. But anyway, in this chapter we've got fundamentals of expressions. We got arithmetic operators, logical and relational operators, assignment operators, increment and decrement operators, the member access operators, conditional operators, bitwise operators, sidewise operators, comma operator, type conversions. Ooh, that'll be fun. Operator precedence table. That's it. That is it. So we're gonna do we just gonna continue on this? There are so many sharp includes. Ooh. I just have a white screen. Thank you. You lose my page as well, didn't you? Adobe Acrobat Reader, can you not? I know the hardware that you're running on is not the newest of hardware, but please, it works good. It works good. A few fundamental concepts that affect how expressions are evaluated. Start briefly by discussing the concepts that apply to most, if not all, expressions. Subsequent sections will cover these topics in more detail. So, okay. So this is sweeping. This is gonna address. Why is there just too much weight on you? I don't get it. Why? Oh, is no? It's not being pinched. Is it you? I think it's the webcam. It's kind of zap strapped across 2 of the beams. The beams obviously don't maintain an equal distance when they're moving. I think it was causing some rub, causing it so that my boom was not moving correctly. Anyway, or staying in position rather. It was squeezing it, so it was pushing it out of position. So both unary and binary operators. We got the address and the dereference, which are unary. You got the equality, multiplication, etc., which are binary. They are 2 operands. Cool, it's cool. We know that already. It's all good. Understanding expressions with multiple operators requires understanding the precedence and associativity of the operators and may depend on the order of evaluation of the operands. For example, following expression depends on how operands are grouped to the operators. Yes, we've got 5 plus 10 times 20 divided by 2. Obviously, you can apply some BODMAS to that, and we can understanding such expressions is the topic of the next section. So, big tip. This is we may be just going to breeze through this little section because I did maths A level. Wow, the last subject that was pertinent and relevant to my actual interests. Apparently, maths A level more than 10 years ago. But ignore everything I just said. What? But I'm pretty sure they're going to tell us, hey, by the way, BODMAS is not intrinsically supported in C, buddy. We just want to make it hard for you, you know, bro? But it's not about that. It's he says, look. Evaluation expressions are often converted from one type to another. Bad. Binary operators usually expect operands with the same type. Okay, that's fine. Operators can use operands of different types as long as the operand can be converted to a common type. So there's some weird funkiness about using floats and ints together. Ideally, you'd use just all floats or all ints, but I've seen the conversion in C++ from a float to an int simply truncates any float value it had. Welcome to the Math Noise stream, by the way. Do you like how visual these streams are? You know, the nice black screen with some text that occasionally changes. Here we go. The rules are somewhat complicated. For the most part, conversions happens in unsurprising ways. We can convert an integer to floating point and vice versa, but we cannot convert a pointer type to floating point. Or pointers aren't like that, man. The memory addresses. 1, they're ints. But 2, they're not numbers. They're addresses of memory. Right? Am I right? Remember that time when I thought I'd be real clever, and to get the value inside a pointer, I actually just printed the pointer by accident, and it just gave us like a whole bunch of memory addresses. That was fun. Fun times. Language defines what operators mean. Okay. What may be a bit surprising is that small integral type operands, bool, char, short, etc., are generally promoted to larger integral type, typically int. Okay. What? Okay. The language defines operands mean apply to built-in compound types, blah blah blah. Overloaded operators. Okay, here we go. Define most operators class. Alternative meaning to an existing operator symbol, we refer to them as overloaded operators. Okay. Our library input and output operators, and the operators used with strings, vectors, and iterators all over overloaded operators. Okay. Okay, so including the types of its operands and the result depend on how meaning of the operator depend on how the operator is defined. Okay. However, the number of operands and the precedence and the associativity of the operator cannot be changed. What? As an R value or an I value inherit named Z and originally simple mnemonic purposes. I values could stand on the left side of an assignment, whereas R values could not. C++ distinction is less simple. In C++, I value expression yields an object or a function. However, some I values, such as const objects, may not be on the left-hand operand of an assignment. Moreover, some expressions yield objects but return them as R values, not I values, roughly speaking. So an R value, generally speaking, is going to be a value, the meat and potatoes information of an object, and the I value is going to be, it says the object's identity here, but yeah, location in memory, yeah, its address, a pointer to, a reference of, maybe the name of the object, but not what the object contain. Okay, this is, you know when you start reading a book and your brain just starts leaking out your ears? Yeah, boy. Sometimes I feel like learning C++ is making me more stupid. when we use an I value in place of an R value, the object's contents, its value used. So if you use an object in C++ that's called an I value, that's referred to as an I value, in the position of an R value where it can be put, if it is an I value that can be put in the position of an R value and not something like a const, that is on the left hand side of an expression, the I values, R value values are used. So its contents, its value, its number, vector stuff, whatever it is, the inside bits are used, obviously. Duh. I feel like this bit is just really overcomplicating things a little bit, you know? Absolutely. Assignment requires a non-cost I value as the left-hand operand. Boom. And yields its left-hand operand as an I value. Okay. The address of operator requires an I value operand and returns a pointer to its operand as an R value. Oh. Of course. Because it's the pointer thing. The built-in dereference and subscript operators and the iterator dereference and string and vector subscript operators all yield I values. Okay. Because the pointers, right? The subscript gives you a pointer to the location in memory of the value at that position in that vector, array, string, whatever you're doing, right? Maybe? Help. The built-in and iterator increment and decrement operators require I value operands, and the prefix versions, which are the ones we've used so far, also use I values. Oh, okay. Do they? Wow. As we present the operators, okay. L values. It's a lowercase l. It wasn't an I. I thought it was an uppercase I. Fuck. So, someone can go back and just overdub me saying L value. L value. L value? Over the top of wherever I said I value. Don't worry about it. L values and R values also differ when used with declaration type. When we apply declaration type to an expression, the result is a reference type. If the expression yields an L value, as an example, between P is an int star pointed to an int, because the reference yields an I value, L value. Fuck! L value. Declaration type star P is an int and. On the other hand, because the address of operator yields an R value, declaration type and P is an int star star, that is a pointer to type int. Okay, I'll take your word for that. Here's what we came for. An expression with two or more operators is a compound expression. Cool. A val-to compound expression involves grouping operands into the operator's precedence and associativity to determine how the operands are grouped. Cool. So this is BODMAS, and this is right? So you kids remember BODMAS, and this is an important lesson for everyone to take home who wants to do maths without brackets. You fucking sadist. Don't. Maths without brackets is just... my eyes bleed, okay? Organize your fucking sums. Jesus, so hard. I like two-dimensional layouts of sums. They look cool. But you know, so when you have something divided by, there's, you know, a full horizontal line, and it's a nice visual break. Although I can understand why some people would use decimal multiplications or single line strokes. You know, if they're lazy, if they can't format things. But the perfect horizontal line is itself a set of brackets. Because, for example, here we've got a sum. I'm going to skip the first two and go to this third one. 6, and I'm reading just left to right. There are no brackets. 6 plus 3 times 4 over 2 plus 2. If you have the horizontal bracket, you'd know instantly if that was over 2 plus 2 or over 2 plus 2. You know what I'm saying? Because the 2 and the plus 2 would either be on the end of the bracket, in the middle, or on the top, or it would be underneath the bracket, underneath the division line with the other 2. In this case, it is at the end of the brackets, obviously, because BODMAS dictates that it must be. Yeah, so BODMAS is brackets, order, division, multiplication, addition, and subtraction in that order. And there's another one. The American ones, they have a different, something with an I, because they use indices instead of order. Fucking, I don't know. Anyway, it's not the point. They're both the same system practically. And we would evaluate this as, you know, 3 times 4 over 2 plus 8, because, you know, 6 and 2, and then you have multiplication, you have division. 3 times 4 is 12. 12 over 2 is 6. 6 plus 6 is 12. Plus 2 is 14. And that is exactly what this has resulted. If you type that into C and you type x equals 6 plus 3 times 4 divided by 2 plus 2, it will be 14. If you want it to be a different number, you're going to have to start using brackets to separate these expressions out, okay? Kids, that's just the beginning and the end of the situation, I'm afraid. Also, science and technology, is that new? Because I've just been doing these under just chatting, and I feel like maybe that was misrepresenting my brand as a slightly more down to learn kind of bro, you know. Here we go. But then we've got here, because of precedence, the expression 3 plus 4 times 5 is 23, not 35. Of course, BODMAS, you do the 4 times 5 first, which is 20, and then you add the 3. But associativity I've never heard of, and this is a triple subtraction, which is like the only time subtraction isn't the same as addition. It's adding negative numbers together, right? I mean, in this instance, the answer is exactly adding negative numbers to a positive number. Negative 15 and negative 3. You gotta... Negative 15 minus 3 is negative 18. I mean, that works both ways. The thing is, right, okay. So it's 20 minus 15 minus 3. I may have said that already, I don't know. And so, like, I know you're thinking like 20 minus a positive 15 value minus a 3 positive value, right? And you'd think that's cool. But really, you should think about taking away, like adding a negative number. So we have positive 20, add negative 15, add negative 3, right? Because that's the way they combine logically. That's the way they combine in C++. And if you think about this like, oh, 20 minus positive 15 minus 3, that's incorrect. You have a negative symbol there. That 15 is a negative. It's not a positive. It's literally the negative symbol is a minus. It's why it is stop me, okay? That's just take it as it is, okay? You know what I'm saying? You know what I'm saying? You know, because if you take out the 20, right? The negative symbol is bound to that number 15. It's not bound to the 20. So your positive and your negative expressions are the left-hand side of your number, right? And if you take the 20 off, which is what we're minusing, we've got minus 15 minus 3, which is minus 18. The only way that this would be 8, as the book suggests you might think it would be, ever, is if it was 20 minus, in brackets, 15 minus 3, end brackets. At that point, you have a positive 15 reduced by a negative 3, right? Yeah, we're all on the same page. It's a negative 15. Boom. Next question. Sorry, did I just ramble for like a full 5 minutes about maths? About one negative number. Anyway, BODMAS is boring, and people who don't understand it need to go to the Wikipedia page for BODMAS. Parentheses override precedence and associativity. Yes, they do. Use parentheses to sort your fucking sums out. You goddamn heathen! Sorry. Precedence and associativity matter. I've already seen examples of precedence affects the correctness of our programs. For example, consider the discussion in 353, page 120, about dereference and pointer arithmetic. What? Yeah, okay, so I think the example they're giving about where we've already seen associativity at work is a little bit misleading, because the associativity that they're talking about is pointer assignment, which I guess in C++ and C in coding, okay, pointer assignment is going to go maybe hand in hand with arithmetic. So I guess you do have to watch out for that one, yes. And I'll open it up. I will open it up. Last week we did not watch out for that. Right there. Boom. And it took us, what, 20 minutes to get that correct? The in brackets star p, end brackets, square brackets 4. Because if you don't have the brackets, it's an int star p and not an int star p4, right? It's a point. It's an array of 4 pointers. No. So this is a pointer. Yeah. This is a pointer to a size 4 array of ints. But if you have the brackets missing, it's a pointer to an array of pointers. It's an array of it is just an array of pointers. It's an array of 4 pointers. 4 pointers to int. Yeah. Okay, yeah, we got that done. So that is associativity, okay? And it matters. Associativity is possibly more important than BODMAS. BODMAS is a fairly intrinsic and well-used mathematical system accepted by large swathes of the modern world. But associativity is going to come and be a natural pain in your programs and my programs if you don't watch out for it. Yeah, alright, okay. Associativity branches out into, you remember those, how long ago was it now? But there's it says output expressions, but we were doing a thing. We were concatenating C++ strings, and there was something about not being able to concatenate a certain type of initialized string with another one because of associativity or something. I don't know. That's why. Do we have strings up here? I don't think I actually. Stop ruining my formatting. Every time I scroll up, it just moves them around. Visual Studio is very helpful for highlighting code, but I, honest to God, hate the fact that it's trying to format my stuff. Fuck off. But I'm sure. Okay. This is going to be a short one. We've got to the exercises already. Table 4.2 lists all the. Oh yeah, okay. So IO, yeah, okay. IO. C in V1, V2. So read into V1 and then V2. Operators have the same precedence and have higher precedence than operators in subsequent segments. For example, prefix increment and dereference operators share the same precedence, which is higher than that of the arithmetic operators. Ooh! Get that, BODMAS. C++ BODMAS. There you go. Boom. For example, blah blah blah, blah blah blah. Table includes a page reference to each operator's description. We have seen blah blah blah. Okay, that's nothing that we can do here. Okay. What is the value returned by 5 plus 10 times 20 divided by 2? Boom. $105. Just at a. Oh no, wait. BODMAS. I'm an idiot. It's still 105. Haha! And that's where we come on to our second point, where addition and subtraction can be maybe confused as being slightly different. Division and multiplication are, if you've got a whole bunch of things. I'm trying to think of an instance where that's wrong. I'm pretty sure there's an instance where that's wrong. But division and multiplication are exactly the same. Like, exactly the same. So, like, this is 10 times 20 times 0.5, right? Right? Because 10 times 20, 200, divided by 2, 100. 20 divided by 2, 10, times by 10, 100. It's the same either way you do it. 10 divided by 2, 5. 20 times 5, it's 100. And that's completely the wrong order that they've given it to us, okay? So I'm pretty sure 99 out of 100 times multiplication and division can be done simultaneously, as long as they're all in a block, right? If there's an addition to the side of the multiplication, it's gonna be wrong, because then you're gonna have to consider your brackets. Also, always consider your brackets. Using table 4.12, page 166. Okay. Parenthesize the following expressions to indicate the order in which the operands are grouped. Star vec dot begin and star vec dot begin 1. So I believe star vec is in brackets and then dot begin outside of the parentheses, and then in one set of parentheses you have star vec, and then a second set of parentheses. I'll just write it out, okay? So the first one would be and the second one would be, oops, no. Because as we learned not 5 seconds prior to doing this example, arithmetic operators are at a lower precedence than the left-hand operators, than the left-hand operands. Is that what they're called? Left-hand operands. And left-hand operands have the highest precedence. And if we didn't, that's right. Yeah, the left-hand operand has no, not operands. What are they called? Fuck, we did this like 2 seconds ago. What they fucking called? What are they called? What are they called? Whatever they're called. The pointer assignment operator, the star to the left-hand side of vec, okay, as descriptive as we can possibly be, because I've forgotten the fucking word. Goddamn useless at this shit. The star to the left-hand side of vec is the almighty grabalon, and we'll grab the first thing it grabs. So without any parentheses, this is how it's going to grab. It's going to be a pointer to vec, and we're going to dot begin, which is going to return a pointer to vec. So God help you if you've got stuff going on, that you've got weird shit like that you can do. But okay. And then the next one, we go down and we have dot begin in parentheses, just to make sure you know that the thing is gonna proceed to the right. Without the parentheses, it will still work like this. It will do dot begin +1, so it will be the next operator. It will be the second value in your pointer to a pointer of whatever you're doing. Yeah, I'm pretty happy with those answers, and that is the end of that section. We're going to be going into 4.1.3 order of evaluation. Do I dare continue right now? Okay, it was just only a short thing. Okay, so this is only a short little section, so we'll try and get through it as well. Precedence specifies how the operands are grouped, says nothing about the order in which the operands are evaluated. In most cases, the order is largely unspecified in the following expression. Oh. Unspecified. Full stop. In the following expression. In I, f1 times f2. Now, f1 and f2 must be called before the multiplication can be done. After all, it is their results that are multiplied, however, with no way of knowing if f1 will be called before f2 or vice versa. For operators that don't specify evaluation order, it is an error for expression to refer to and change the same object. Expressions that do so have undefined behavior. Oh, I see. As a simple example, the output operator makes no guarantees about when or how its operands are evaluated. As a result, the following expression is undefined. In I, see out I space plus I end line. Oh shit. That's weird, man. This is weird. No, this is weird. What the hell? So, right, okay. So, stuff to the right-hand side of the equation of the whatever you're doing on that line is evaluated at random, quote unquote. There's no specification on how they're evaluated. So you can't do, so I, cout I space plus plus I end line, you can't do that because it doesn't know if it's going to print I first or if it's going to increment I first, which is understandable, I guess. And I guess it's understandable that people wouldn't know. See, I'm confused, right? And it's understandable that I would be confused, but I'm being told this, so I don't do it. And I'm confused because obviously you just do things left to right. Duh. Fucking stupid computer. They should put that in. They should just put that in. And then you can do stupid stuff like this, right? Causes for identified, drawing conclusions on how to behave. It might print out 0, 1. It might print out 0, 1, 1. Program is an error, regardless of what code the compiler generates. Okay. For operators do guarantee order, and which operands are evaluated. So, logical AND operator guarantees left-hand operator is valued first. Moreover, guaranteed the right-hand operator is evaluated only if the left-hand operand is true. Ooh, damn. The only other operator that guarantees the order operator is evaluated the logical OR get operator. The conditional question mark colon operator and the comma. All right. Oh, right. The conditional operator is a question mark and then a colon. Okay. Order of an operand is evaluated as independent of the precedence and the associativity. In an operation, expressions such as f plus g times h plus j. Precedence guarantees the results of g and h are multiplied. Associativity guarantees that the results of f is added to the product of g and h, and the result of the addition is added to the value of j. No guarantees of the order in which these functions are called. If f, g, h, and j are independent functions, do not affect the state of the same objects or perform I/O, then the order in which the function is called is irrelevant. If any of these functions do affect the same object, then the expression is an error and has undefined behavior. Holy shit. That is deep, that is dark, and that is something that I am not going to touch. What the fuck? So, if you are doing arithmetic with functions that change the value of the same object, you can't, because there's no way of telling how your compiler is going to write machine code to evaluate the expression. So you may have, I'm guessing one, it's just going to throw up an error in your writing boy in Visual Studio. Holy shit, can I breathe? It's going to throw up an error maybe in your IDE, and then if it doesn't throw up an error in your IDE, when you run it, it might throw up an error, it might crash, and then if it doesn't throw up an error or crash, you might have just random results in the thing. I understand. Exercise 4.3. Order of evaluation for most binary operators is left undefined to give the compiler opportunities for optimization. Oh, idiot. Don't do that. This strategy presents a trade-off between efficient code generation and potential pitfalls in the use of the language by the programmer. Do you consider that an acceptable trade-off? I just said no. Why? Why not? Well, because sometimes you want to get crazy. You want to get loose, dog. Sorry, I've gone off the train. So basically, I would maybe prefer it if it worked from left to right, evaluating the things, or if it evaluated the things in the order of BODMAS, if you were in fact doing BODMAS, or if it evaluated things. I guess it's getting. Is it getting too much to ask for the compiler to like work that shit out itself? Like, come on, man. Like, if I have a function, if I have 4 functions that all change x, I even know an opportunity where I would do that. You know what? I don't care. It is what it is. C++ is that way. It was written by people who aren't me, and if I want to change it in a different way and I see it fit in the future, I'll just write my own goddamn C branch. I'll call it C Bismillah. Anyway, we're done here. we're done here. We'll do the arithmetic operators next time. My throat's getting a bit dry from the old talking. Hope to have some Unreal garbage going up this evening. I don't know when exactly it's going to happen, but it will happen. I've woken up nice and early and I am awake and refreshed, and I'm sure I won't crash sometime in the mid-evening and decide that I'm either too tired or unmotivated to work on the thing. I'll work on the thing, and then tomorrow you can laugh at me when I didn't come stream the thing working on the thing. Hey, it's not fun. So, that is the end of today's session. We didn't write any code today because we were doing arithmetic, and I feel like it's below us now, really. I didn't learn maths for the first 19 years of my life to have it rubbed in my face that, oh hey look, there's maths you can do. Is there anyone on this planet that like dropped maths? Of course there is. No one, like barely anyone took A-level maths. What the hell? Like I remember at my school, it was like, oh, you taking A-level maths? And like, you're a nerd taking A-level maths. It's like, why? What the hell, man? Maths is like the most important subject. Sure, there's a whole lot of sorry, you can hear that, can't you? Shit. There's a whole lot of abstract stuff you probably never use, or very rarely use, like integration, differentiation. Actually, hey, boom, you know what? In some jobs, you do actually use those. Haha. And also, not just in jobs, but also in things like, I guess there would be jobs, but you can do them as a hobby as well. But processes like modeling, imaging. Not modeling and imaging, but like theoretical models, not 3D models, you know, like waveform modeling and stuff. And I'm sure you. Thanks for watching the live video. If you can watch the live video, thanks for watching the video on demand. If you're watching the video on demand, I'm about to go clean my brain off with a spatula. And as always, I will see you in the next episode.